Hello, my name is Steven Sellen and I will be explaining how to use the chain rule. The chain rule is basically a method that uses partial derivatives in order to find the change in a function z equals f of xy, where x and y could also be functions of t with respect to t. You want to find the change in the original function z with respect to t when the original function z is a function of described by x and y. Okay, so you'll need a couple factors in order to do this. You'll obviously need an original function z that is a function of x and y, and you will also need both the x and the y variables to be functions of t. So I thought this was shown pretty clearly in the wheat production from our homework. Uh, the wheat production example, it showed the effect of rainfall and temperature on wheat production. So in this case, the rainfall would be your x variable, and the temperature would be your y variable, and the wheat production would be your z. So in order to find the wheat production with respect to t, which in this example was time, we also needed our rainfall and temperature to be functions of t. And the example had given us both the average rainfall per year and the average temperature per year, and the change in the average rainfall and temperature per year. So since we had all this, we were able to follow a formula to find the change in wheat production per year, which was t. The formula that we used, you can see right down here. It would be, in order to find the change in z with respect to t, which is dz over dt, you have to do dz over dx multiplied by dx over dt, and then you have to add dz over dy multiplied by dy over dt. As you can see here, if you cancel out the dx's, I'll highlight them in red. If you cancel out both the dx's, you're left with dz over dt, which is what you want, but you can't forget about your y variable. So you also have to do the second part of the formula, but the dy's also cancel out, as shown here. And you can see that now, after doing this, you're left with the change in z with respect to t, which is what you're looking for. And that's basically a good formula for the chain rule. There's another method to do it, which I'll show in my second example, but first let's see how to use this first method. So as you can see, chapter 13.5, here's example number 1. They provided us with a formula w equals x squared plus y squared, and they also gave us x equals 2t and y equals 3t, and asked us to find dw over dt. So what I recommend as your first step, if using this method, just write out the chain rule formula at the top right away. Write it out. It'll make everything straightforward, and then you just have to find your components and plug them into this formula. So what I would do, just go from left to right, right in the formula, find each component. So first, you want to find dw over dx, which is the partial derivative of w with respect to x. In this case, that turns out to be 2x. And next, find the derivative of x with respect to t, which happens to be 2. And do the same for the partial derivative of w with respect to y, and the derivative of y with respect to t, which are 2y and 3, as shown right here. So next, you just plug them into the chain rule formula, which is up here. So as you see, you have dw over dt would equal 2x times 2 plus 2y times 3, giving us a final formula of 4x plus 6y. And now this could be a formula for the change in w with respect to t, but we want it in terms of t. Since it's with respect to t, you need to find it in terms of t. That's simply done just by plugging in the values of x and y, which at the top was shown as x equals 2t and y equals 3t. So you plug those in, and the change in w with respect to t turns out to be 26t. So that's how you would go about using the chain rule to find the change in w with respect to t, by using the formula. Now we'll go on to the other method. The other method would be, before anything, rather than using that formula, simply just define W in terms of t. So as you see here, number 7, they gave us the formula W equals x squared plus y squared plus z squared, and then they gave us values for x, y, and z, as shown right here. And they also wanted us to find the change in W with respect to t. But this time, instead of going through finding the partial derivatives and all those components, you could simply just define W with respect to in the terms of t. So plug in the x, y, and z values. As you see, I put them in parentheses here to make it clear. And W would equal cosine of t squared plus sine of t squared plus e to the t squared. Now that you have W in terms of t, dW of dt is easy. You just find the derivative of W with respect to t. And that's shown right here. It would equal negative 2 sine of t times cosine of t plus 2 sine of t times cosine of t plus 2 to the e to the 2t. I didn't show it here, but as you can see, the negative 2 sine of t times cosine of t and the positive 2 sine of t times cosine of t could cancel out, and that leaves you with the formula of the change of W with respect to t, simply 2e to the 2t. Now, these are two methods of finding the chain rule. Whichever one's more clear to you, go ahead and use that one. I hope this video helped to clear them both up, and you'll have no problems with them in the future. Thank you.